On the morning of September 8, 1944, beneath a gray sky over London, the war arrived without warning. There was no formation of aircraft crossing the horizon, no engine roar approaching from the clouds, no air raid sirens giving civilians precious minutes to reach shelter. Instead, a strange mechanical sound appeared above the city, followed by an unnatural silence. Moments later, a devastating explosion tore through the streets. The weapon responsible was unlike anything Britain had faced before. It did not come from a bomber aircraft. It did not follow a traditional flight path. It was not a conventional bomb dropped from above. It was a new kind of weapon, launched from hidden positions across occupied Europe, designed to bring terror directly to the enemy's homeland. The Germans called it the Vergeltungswaffe II, the Vengeance Weapon II. To the world, it became known simply as the VU-2 rocket. Traveling faster than the speed of sound, rising beyond the reach of Allied fighters and anti-aircraft guns, the V-2 represented a terrifying leap into the future of warfare. It was the first long-range guided ballistic missile ever used in combat, a weapon that seemed to arrive from the edge of science fiction. But behind the image of technological brilliance was a far darker reality. The creation of the V-2 was not only a story of engineers, calculations, and advanced rocket science. It was also a story of desperation, forced labor, and the enormous human cost hidden beneath Nazi Germany's pursuit of a miracle weapon. In the underground factories where these rockets were built, thousands of prisoners worked under brutal conditions. Many would never see the weapons they helped create launched into the sky. Their suffering became part of the same technological achievement that Nazi leaders hoped would reverse a war they were already losing. By the time the first V-2 struck London, Germany was fighting for survival. The Allied armies had broken through France after the success of the Normandy landings. Soviet forces were advancing relentlessly from the east. German cities were being destroyed by Allied bombing campaigns, and the once powerful Wehrmacht was struggling with shortages of fuel, equipment, and manpower. Yet inside Nazi Germany, Adolf Hitler and his military leadership searched for a weapon that could change the course of history. They believed advanced technology could overcome strategic defeat. The VU-2 was their most ambitious attempt. It was a weapon built on an extraordinary idea. Instead of sending an aircraft into enemy territory, Germany would send a projectile into the upper atmosphere and allow gravity to carry it down onto its target at immense speed. The concept was revolutionary. A conventional artillery shell followed a predictable arc. An aircraft could be intercepted. A bomber could be shot down. But a rocket, traveling thousands of kilometers per hour, reaching the edge of space before descending almost vertically, presented a completely different challenge. For the first time in warfare, there was almost no defense against an incoming attack. The missile could be heard only after it had already arrived. This was the nightmare that Allied intelligence had feared. For years, British and American analysts had searched for evidence that Germany was developing powerful new weapons. Reports from occupied Europe described strange research facilities, unusual military activity, and experimental launches. At first, many observations were uncertain. Some information appeared impossible. A weapon that could travel from continental Europe to Britain through the upper atmosphere seemed beyond practical engineering. But Germany's rocket program had been developing for more than a decade. Long before the Second World War began, a group of German scientists had become fascinated by the possibility of space travel. Among them was a young engineer named Wernher von Braun, who believed rockets could eventually reach beyond Earth itself. During the 1930s, however, these scientific ambitions became connected with military objectives. The German army recognized that rockets could provide a new form of artillery, one that could strike targets at distances impossible for traditional weapons. In 1936, construction began on a major research center at Peenemünde, a remote island facility on Germany's Baltic coast. Here, scientists and engineers worked to transform theoretical concepts into a functioning weapon. The challenges were enormous. A rocket powerful enough to travel hundreds of kilometers required engines capable of producing enormous thrust. It needed a guidance system that could maintain accuracy despite extreme speeds. It required lightweight materials strong enough to survive violent acceleration and the intense heat of re-entry. Every component represented a problem that had never been solved before. The rocket had to carry fuel, oxygen, control systems, and explosives while remaining light enough to leave the ground. It was a machine attempting to escape Earth's gravity and then return with deadly precision. The first attempts were failures. Rockets exploded shortly after launch. Engines burned unpredictably. Guidance systems malfunctioned. Years of testing produced countless setbacks, but German engineers continued refining the design. According to wartime records, the program consumed vast resources at a time when Germany's conventional military forces desperately needed weapons, vehicles, and supplies. Yet Hitler's leadership increasingly viewed advanced weapons as a path to victory. The V-2 became more than a military project. It became a symbol of Nazi Germany's belief that technology could defeat reality itself. By 1943, however, the program faced a major crisis. The Allies had discovered Peenemünde. In August 1943, the Royal Air Force launched Operation Hydra, a major bombing raid against the research center. The attack caused significant disruption and forced Germany to move much of the production effort underground. The new location would become one of the darkest chapters in the history of the V-2. Deep beneath the mountains of central Germany, inside the Mittelwerk underground factory near Nordhausen, thousands of prisoners from the Mittelbau-Dora concentration camp were forced to manufacture the rockets. The conditions were horrific. Workers carved tunnels through solid rock, assembled machinery, and produced weapons in a vast underground complex where exhaustion, starvation, and disease were constant realities. Records suggest that more people died producing the V-2 than were killed by the weapon during its combat use. The rocket that represented the future of warfare was created through methods rooted in exploitation and suffering. Yet, despite the terrible cost, German engineers continued their work. By 1944, the weapon was ready. The first operational launch would soon send a new kind of attack towards Europe, and when the first V-2 rose into the sky, the world entered a new age of warfare, one where the battlefield was no longer limited to the ground beneath soldiers' feet, but extended into the atmosphere above them. Part 2. The development of the V-2 rocket had transformed a dream once associated with space exploration into one of the most destructive weapons of the Second World War. But creating the concept was only the beginning. Turning a fragile experimental machine into a reliable weapon of war required years of engineering, thousands of workers, and an industrial effort that stretched the limits of Nazi Germany's remaining capabilities. At the heart of the project was the work of the German Army's rocket research team at Peenemünde. Under the leadership of scientists and engineers including Walter Dornberger and Werner von Braun, the program attempted to solve problems that had never been faced on such a scale. The V-2 was officially designated the Aggregate 4, or A4, during development. It was a single-stage ballistic missile approximately 14 meters long, with a diameter of around 1.65 meters and a launch weight of roughly 12.5 tons. Its body was constructed from lightweight steel alloys, designed to withstand enormous forces during flight while carrying a warhead of approximately 1,000 kilograms of explosives. The rocket's most important innovation was its propulsion system. At its core was the revolutionary A4 engine, a liquid fuel rocket motor that burned a mixture of liquid oxygen and ethanol. Unlike traditional artillery weapons that relied on chemical propellants contained inside a shell, the V-2 carried its own fuel and generated thrust by creating a continuous controlled explosion inside the engine chamber. The power produced was extraordinary. The engine generated around 25 tons of thrust at launch, forcing the rocket upwards from its launch platform with a violent force that shook the surrounding area. A weapon that weighed more than 10 tons could accelerate from a stationary position and climb rapidly towards the edge of the atmosphere. The rocket's flight was controlled by an advanced guidance system consisting of gyroscopes and an automatic control unit. These systems measured the missile's movement and adjusted its trajectory using internal steering mechanisms. Small control surfaces, known as graphite vanes, were positioned in the exhaust stream to alter the direction of thrust during the early stages of flight. To ordinary soldiers and civilians during the war, the technology appeared almost impossible. The V-2 did not travel like an aircraft. It did not need wings to remain airborne. Instead, it followed a ballistic path. After launch, it climbed vertically before reaching the upper atmosphere, traveling at extreme speed before beginning its descent towards the target. Its maximum speed exceeded 5,000 kilometers per hour, making it the first man-made object to achieve supersonic speeds during combat operations. The missile could reach targets approximately 320 kilometers away, carrying its explosive payload at speeds that left defenders almost helpless. However, the technical achievements of the V-2 must be viewed alongside its limitations. Despite its revolutionary design, accuracy remained a major problem. The guidance system was advanced for its time, but not precise enough for pinpoint strikes against individual military targets. The weapon was most effective as an area bombardment system, where entire cities or large strategic zones became the target. The cost of production was also enormous. Each V-2 required thousands of individual components, specialized materials, and highly skilled labor. Estimates suggest that more than 3,000 V-2 rockets were eventually produced during the war, although exact numbers vary depending on how incomplete wartime records are interpreted. The industrial challenge became even greater after the Allied bombing of Peenemünde. Germany responded by moving production underground, with the largest manufacturing operation established at the Mittelwerk facility near Nordhausen. Hidden inside tunnels originally created for storage and mining, the factory became one of the largest rocket production sites in history. But this achievement came at a devastating human cost. The labor force consisted largely of prisoners from the Mittelbau-Dora concentration camp and other forced labor groups. They worked in dangerous underground conditions, often with inadequate food, limited rest, and severe punishment. According to historical research, thousands of prisoners died during the construction and production of V-2 rockets. Exact numbers remain uncertain, but historians agree that the human cost was immense. The weapon that represented advanced engineering was built through a system of exploitation controlled by the Nazi regime. By the summer of 1944, Germany was desperate for a weapon that could strike back at the Allies. The Normandy invasion had opened a Western front that German forces could no longer contain. Paris had been liberated in August 1944, and Allied armies were advancing rapidly towards Germany's borders. Hitler's leadership hoped the V-2 would create fear among Allied populations and demonstrate that Germany still possessed the ability to fight back. The first combat launch took place on September 8, 1944. 2 rockets were launched towards Paris and London. One of them struck near Paris, while another landed in the Chiswick district of London, killing several civilians. Unlike the V-1 flying bomb, which had already terrorized Britain during the summer of 1944, the V-2 created a different psychological experience. The V-1 could be heard approaching. Its distinctive pulse jet engine created a terrifying sound across the skies, and civilians knew that when the engine stopped, an explosion was moments away. The V-2 was different. There was no warning, a flash in the distance, a sudden impact, a building destroyed before anyone understood what had happened. For those living beneath its path, the weapon seemed almost supernatural. Between September 1944 and March 1945, Germany launched thousands of V-2 rockets against Allied targets. London remained the primary target, but missiles were also fired at locations including Antwerp, Liège, Hasselt, and other Belgian cities. Antwerp became one of the most heavily attacked locations because of its importance as an Allied supply port. The city was essential for delivering fuel, ammunition, and equipment to advancing Allied armies. According to wartime reports, the attacks caused significant civilian casualties and created widespread fear, but they did not achieve the strategic transformation Nazi leaders had hoped for. The V-2 could destroy buildings and kill civilians, but it could not stop advancing armies. It could not repair Germany's collapsing military position. It could not reverse years of battlefield losses. Yet every launch demonstrated something unprecedented. Humanity had entered the missile age. The same technology designed by Nazi Germany to strike its enemies would soon become the foundation of a new era in military engineering and space exploration. Before that future could begin, however, the V-2 had to face its greatest test. Not in the laboratories beneath Germany, but on the battlefields and cities where its deadly power would finally be unleashed. Part 3. The arrival of the V-2 rocket over Europe marked a turning point in the history of warfare. For centuries, armies had relied on weapons that traveled through the air at the speed of a thrown projectile, a cannon shell, or an aircraft. The V-2 changed that equation completely. It represented a new age where weapons could cross borders in minutes, rising beyond the atmosphere before descending upon their targets. The first combat launch took place on September 8, 1944. 2 rockets were launched towards Paris and London. One of them struck near Paris, while another landed in the Chiswick district of London, killing several civilians. Unlike the V-1 flying bomb, which had already terrorized Britain during the summer of 1944, the V-2 created a different psychological experience. The V-1 could be heard approaching. Its distinctive pulse jet engine created a terrifying sound across the skies, and civilians knew that when the engine stopped, an explosion was moments away. The V-2 was different. There was no warning, a flash in the distance, a sudden impact, a building destroyed before anyone understood what had happened. For those living beneath its path, the weapon seemed almost supernatural. Between September 1944 and March 1945, Germany launched thousands of V-2 rockets against Allied targets. London remained the primary target, but missiles were also fired at locations including Antwerp, Liège, Hasselt, and other Belgian cities. Antwerp became one of the most heavily attacked locations because of its importance as an Allied supply port. The city was essential for delivering fuel, ammunition, and equipment to advancing Allied armies. According to wartime reports, the attacks caused significant civilian casualties and created widespread fear, but they did not achieve the strategic transformation Nazi leaders had hoped for. The V-2 could destroy buildings and kill civilians, but it could not stop advancing armies. It could not repair Germany's collapsing military position. It could not reverse years of battlefield losses. Yet every launch demonstrated something unprecedented. Humanity had entered the missile age. The same technology designed by Nazi Germany to strike its enemies would soon become the foundation of a new era in military engineering and space exploration. Before that future could begin, however, the V-2 had to face its greatest test, not in the laboratories beneath Germany, but on the battlefields and cities where its deadly power would finally be unleashed. Part 3. The arrival of the V-2 rocket over Europe marked a turning point in the history of warfare. For centuries, armies had relied on weapons that traveled through the air at the speed of a thrown projectile, a cannon shell, or an aircraft. The V-2 changed that equation completely. It represented a new age where weapons could cross borders in minutes, rising beyond the atmosphere before descending upon their targets. Yet, on the battlefield of the Second World War, the revolutionary technology faced a difficult reality. A weapon could be scientifically advanced and still fail to achieve the strategic purpose for which it was created. The first operational launches against Allied targets revealed both the terrifying potential and the limitations of the V-2 program. Unlike aircraft or conventional bombers, the rocket could not be intercepted once it began its final descent. Allied fighters could not chase it. Anti-aircraft guns could not accurately track it. Warning systems provided almost no protection. The weapon arrived from above at unimaginable speed. For civilians in London, Antwerp, and other targeted cities, the experience was one of uncertainty and fear. The explosion came without the familiar sounds of approaching aircraft. There was no opportunity to take cover after hearing engines overhead. The damage appeared suddenly, leaving destruction behind before people even understood that an attack had occurred. But despite the psychological impact, the V-2 campaign produced limited military results. The rockets were expensive, difficult to manufacture, and relatively inaccurate compared with conventional bombing methods. Their destructive power was significant, but a single rocket carried a warhead of around 1 ton, devastating to the area it struck, yet insufficient to alter the outcome of a global war. The Allied armies were advancing on multiple fronts, and Germany's industrial system was under increasing pressure. Factories were being bombed, transportation networks were collapsing, fuel supplies were becoming dangerously limited, and experienced soldiers were being lost at a rate Germany could no longer replace. The V-2 was a technological achievement created during a strategic catastrophe. This contradiction defined the final months of Nazi Germany's rocket program. The weapon represented extraordinary engineering, but it was introduced too late and in too small a quantity to change the course of the war. As Germany collapsed in early 1945, the Allies raced to capture the scientists, documents, and hardware connected to the V-2 project. The importance of the technology was immediately recognized. The United States, Britain, and the Soviet Union understood that whoever controlled German rocket expertise would possess a major advantage in the future. Operation Paperclip became the American effort to recruit German scientists, including Werner von Braun and many members of the Peenemünde team, bringing them to the United States to continue rocket research. The Soviet Union also captured equipment and personnel from the German program, establishing its own missile development efforts. The competition for V-2 technology became one of the earliest signs of the coming Cold War. A weapon originally created by Nazi Germany to attack Allied cities would soon influence the development of intercontinental missiles, satellite launch systems, and space exploration programs. In terms of technological design, the V-2 stood apart from earlier weapons. Britain's V-1 flying bomb, also known as the Doodlebug, was a simpler weapon. Powered by a pulse-jet engine, it traveled like a small unmanned aircraft and carried a large explosive charge. More than 8,000 V-1s were launched against Britain during the war, with many aimed at London. However, the V-1 was vulnerable. Allied fighters could intercept it. Anti-aircraft batteries improved their ability to destroy it. Balloon barriers and radar-controlled guns provided additional defense. The V-2 eliminated many of these weaknesses. It was faster, higher flying, and far more difficult to stop, but it was also far more complex and costly. The United States had also begun developing rocket technology during the war, although its programs were not as advanced as Germany's. American researchers studied captured German equipment after the conflict and used that knowledge as part of later missile development. The Soviet Union eventually transformed German rocket research into a powerful missile program of its own. Engineers under Soviet leadership studied the V-2 design and developed increasingly advanced rockets, eventually producing systems capable of launching satellites and carrying nuclear weapons across continents. The comparison between these nations demonstrates an important historical reality. The V-2 was not successful because it won battles. It was significant because it introduced principles that shaped future technology. Its guidance systems, propulsion methods, and aerodynamic design influenced generations of engineers. However, the rocket also revealed the weaknesses of technological obsession without strategic planning. Germany invested enormous resources into advanced weapons while struggling to supply its conventional forces with basic necessities. The V-2 program consumed manpower, materials, and industrial capacity at a moment when Germany needed every resource available for defense. Historians continue to debate the exact military value of the weapon. Some argue it demonstrated the future of warfare and accelerated missile development worldwide. Others emphasize that it was an expensive project that produced limited battlefield impact during the war itself. Both interpretations contain elements of truth. The V-2 was simultaneously a remarkable engineering achievement and a strategic failure. If you're enjoying this journey through history, subscribing genuinely helps us continue bringing remarkable true stories like this to the channel. The legacy of the V-2 extends far beyond the battlefield where it was first used. After the war, rockets based on German designs became central to the space race between the United States and the Soviet Union. The same scientific principles that allowed the V-2 to reach the edge of space would later help humanity place satellites into orbit and send astronauts beyond Earth. In the United States, Werner von Braun and other former German rocket specialists played important roles in developing the rockets that eventually contributed to the American space program. The Saturn V rocket, which carried astronauts to the Moon during the Apollo missions, was built upon decades of research into large-scale rocket engineering. The connection between the V-2 and later space exploration remains one of history's most complicated legacies. The technology represented human curiosity and scientific achievement, but its origins were deeply connected to war, dictatorship, and suffering. The underground tunnels of Mittelwerk, where prisoners assembled rockets under brutal conditions, remain a reminder that technological progress is never separate from the human choices surrounding it. The V-2 was not simply a machine. It was a symbol of ambition, destruction, and transformation. It showed what engineers could achieve when given unlimited resources and a singular purpose. It also revealed the terrible consequences when scientific ability was placed in the